Okay, so for this video, I'm going to talk about all the fraction type exponential equations. So if you want to watch the other video, it should have been before this on the page, but for this video, we're going to talk about all the fractiony exponential equations. So the first thing we're going to look at is, again, our general steps. So the first step is to isolate the base. That means if there's something not part of the original base here, so like this plus 5, you would have to get rid of that 5 first. Okay. Next step is to get the same base on both sides. So if one side has a base of 9, you need to get the other side to a base of 9. And then drop the bases, set the exponents equal to each other, and then solve. Those are our 4 general steps. So looking at this problem number 3, I want to get this left side to a base of 9, right? So I got to see how many times 9 goes into 6,561. Now when it's a fraction like this, we're going to break it down to a base first before we worry about moving it upstairs. Okay, that's the best advice I can give you. Is a lot of students try to move it up first and then break it down. Don't do that. Break it down first, then move it. So we're going to break it down by dividing by 9. And we're going to see how many times 9 goes into 6,561. So divide by 9, and you get 729. So still not there. So divide by 9, and you get 81. So still not there. Going to divide by 9 again, and you get 9. So this tells me how many 9s go into 6,561. There are 1, 2, 3, 4. So I can replace 6,561 with 9 to the 4th. And again, just to double check, I'm going to put it in my calculator. 9 to the 4th is in fact 6,561. So I'm going to replace those, and that gives me 1 over 9 to the 4th is equal to 9 to the negative 2x plus 8. Still not quite the same base though, right? Because this is a fraction. So there's that rule with exponents that if you flip across the fraction bar, you just change the sign of the exponent, right? So if I want this to go upstairs, I just change that positive 4 to a negative 4. So it becomes 9 to the negative 4 is equal to 9 to the negative 2x plus 8. Now our next step is to drop the bases, set the exponents equal to each other. So, oh, my lights went out. Had to go wave at my lights. Okay, so the next step is to just set those exponents equal to each other. So we have negative 4 is equal to negative 2x plus 8. Now it's just a two-step equation, right? You got your acquaintance and your party problem, right? So you'd minus the 8 first. Gives you negative 12 is equal to negative 2x, and then you divide by negative 2 to get x is equal to 6. And again, if that was too quick for you guys, you can always pause and rewind. The beauty of technology. Now let's look at our other fractiony problems. So they're going to be pretty much the same. You're going to get them down to the base first, then move them upstairs by changing the sign of the exponent, and then setting the exponents equal to each other, basically. So this one, I'm trying to get to a base of 8. So I'm going to divide by 8. So 4,096 divided by 8 is going to be 512. So 512, still not there, divide by 8, and you get 64. So still not there, divide by 8, you get 8. So there are 1, 2, 3, 4, 8. So I could replace that with 8 to the 4th, just to double check. 8 to the 4th is, in fact, 4,096. So I think we're done with the steps. Next, so I'm going to rewrite it. So 1 over 8 to the 4th is equal to 8 to the 2x. Now I need to move it upstairs. So to do that, I just change the sign of the exponent. So it becomes 8 to the negative 4th is equal to 8 to the 2x. Now I have the same base. Drop the base at the exponents equal to each other. Gives you negative 4 is equal to 2x. Divide by 2. And you get x is equal to negative 2. And that'd be your answer. Okay. Let's do another one. Let's look at this one. So this one we're trying to get to a base of 7. So I'm going to divide by 7. So 16,807 divided by 7 is 2,401. Divide by 7 is 343. Divide by 7 is 49. divided by 7 is 7. So that is 1, 2, 3, 4, 5 sevens. So again, just to double check, 7 to the 5th is 16,807. So I can rewrite that as 7 to the x minus 3 is equal to 1 over 7 to the 5th power. And now to move it upstairs, I just change the sign on the exponent. So it becomes 7 to the x minus 3 is equal to 7 to the negative 5th. Now I have the same base, drop the base, set the exponents equal to each other, get x minus 3 is equal to negative 5, add the 3, gives you x equal to negative 2. Okay, not too bad, right? And our last one we're going to do here is we're going to get this one to the same, or solve this one. So again, I'm going to break it down to a base of 4. So divide by 4, you get 4. So there are two 4s. So I can rewrite 16 as 4 to the second power. So 4 to the x is equal to 1 over 4 to the second. Still not the same base. Got to move it upstairs. Got to change the sign on your exponent. Gives you 4 to the x is equal to 4 to the negative 2. Now they're the same base. So you drop the base, set the exponents equal to each other. You get x is equal to negative 2. And that's your answer. Again, if you have any problems or questions, talk to your teacher. You can also pause and rewind and go over those problems as much as you need.